Hello friends, welcome to Ivory Gate eLearning series, an academic empowerment program developed by Ivory Gate Education Centre, Abuja, Nigeria. Our subject is mathematics for SSCE and UTME. Topic is indices and standard form. Class objective. At the end of this class, students are expected to understand the meaning of an index, the laws of indices, the expression of numbers in standard form, and finally be able to solve typical SSCE and UTME equations. What is indices? Indices is usually of the expression y raised to power m. Here, where y is called the base and m is called the index. That is where it derived the name indices. Index is the singular of indices. Then it's either you call it index or you call it power, or you call it exponent. So in this case, you can say that m is an index, or is power, or an exponent. Okay, so this really means that y is multiplied by itself m times, where y is called the base, as we've said, and m is called the index, or power, or exponent. Typical example. If, for instance, we have 2 raised to power 5, the normal thing that comes to the mind of students is to say 2 times 5. This is not what it means. Instead, this means 2 multiplying itself 5 times. Here we have 2 times 2 times 2 times 2 times 2 in 5 places. 1, 2, 3, 4, 5. So that is what 2 raised to power 5 means. Then in example number 2, we have 7 raised to power 7. This is not 7 times 7. Rather, it is 7 multiplying itself 7 times. One, 2, 3, 4, 5, 6, 7. Okay, so indices is now aimed at simplifying the solution of numbers. Okay, we go over to laws of indices. The first law of indices says that if we have 2 numbers that have a common base multiplying each other, that it is the same thing as that base, common base, raised to the sum of the indices. A raised to power m times a raised to power n is equal to a raised to power m plus n. Example. Two raised to power 3 times 2 raised to power 2 is equal to that common base 2 raised to power 3 plus 2, which means 2 raised to power 5. If we want to check this, 2 raised to power 3 is 2 times 2 times 2. Times again 2 raised to power 2 is 2 times 2. So you can see that this is now 2 raised to power 1, 2, 3, 4, 5, as we had in the introduction. Okay, laws of indices number 2. This says that a raised to power m over a raised to power n is equal to a raised to power m minus n. This time it is not addition. Then example, we have, for instance, 2 raised to power 3 divided by 2 raised to power 2. This law says that it is the same thing as 2 raised to power 3 minus 2. And this gives us 2 raised to power 1, which is 2. Okay? Then, if we check this, just to cross-check what we'll get with this, we now say 2 raised to power 3 is 2 times 2 times 2 divided by 2 raised to power 2, 2 times 2. Then this can go for this. What are we left with? 2, which is the same thing as this. Okay, then we go to number 3. This has that 1 over a raised to power n is equal to that base raised to power minus the exponent. For instance, if we have 1 over 2 raised to power 2, it is the same thing as 2 raised to power minus 2. Law number 4. A raised to power m brackets and n is equal to a raised to power mn. Most often we know that brackets means multiplication in mathematics. So in this case, if we have 2 raised to power 3 all raised to power 2, this is the same thing as 2 raised to power 3 times 2. And this is the same thing as 2 raised to power 6. Then, number 5. If we have a raised to power 1 over n, that it is the same thing as nth root of a. A raised to power 1 over n is equal to nth root of a. So, example, if we have, for instance, 8 raised to power 1 over 3, so this law is telling us that it is the cube root of 8. And what does this mean? It means what will multiply itself 3 times to give us 8. And what is it? 2. Let us check it. 2 times 2 times 2 will give us 8. So our answer here is 2. The cube root of 8 is 2. We go to law number 6. Law number 6 now takes law number 5 further. A raised to power m over n. Instead of 1 over n, we now have another figure here, in this case another letter as the numerator. So this is the same thing as nth root of a all raised to power m, or nth root of a raised to power m. Either way, the only thing is that taking the nth root in most cases is simpler than taking the nth root of the number raised to power m. Example, given 8 raised to power 4 over 3. This tells us that it is cube root of 8 all raised to power 4, in which case it will give us Cube root of 8 is 2 raised to power 4. In that case, the answer is, we take 2 by 2 and 2 by 2. 2 times 2 is 4 times 2, 8 times 2, 16. Okay, law number 7. If we have a raised to power 0, any number, in fact, any number raised to power 0 is 1. So in this case, if we have 8 raised to power 0 is 1. Then our normal 2 raised to power 0 is 1. So 168 raised to power 0 is 1. Okay. Then we have law number 8. Law number 8 says that things that have the same base, when things that have the same base are equal to each other, then their exponents are equal. So in this case, 2 raised to power x, if we have that, it is equal to 2 raised to power 3. Therefore, x is equal to 3. So these are the laws of indices. Quickly, we go through them again. The first one says a raised to power m times a raised to power n is equal to a raised to power m plus n. So here, because of the multiplication, the sign in between will be addition. Then the second one says a raised to power m divided by a raised to power n is equal to a raised to power m minus n. Here, the division here goes with subtraction. Then 1 over a raised to power n, that is the reciprocal of a number, is that base raised to power minus that index. Then a raised to power m, then into n, then we have this is a raised to power m n, which means m times n. Then the fifth one, a raised to power 1 over n, is nth root of a. Then we go over to the sixth one, which is just taking the fifth one further. A raised to power m over n gives us the nth root of a, all raised to power m, or n into a raised to power m. But we've already emphasized that the first one is always simpler. Law number 7. Any number raised to power 0 is equal to 1. Then finally, we have that if a raised to power m is equal to a raised to power n, then m is equal to n. In that case, their indices are the same. And let's take some examples to drive this home. Example number 1. Okay, so in solving mathematics, there are some ground rules we need to observe. The key thing is clarity. You need to write such that the examiner will easily understand what you are doing and be able to follow the logic of your solution. So the first thing I advise that you do is that you always write the number. In this case, 1a. So this tells the examiner the question you are solving. Then another thing is that you have a column by the side where you do your rough work. Typically in exam situation, they usually mark out a place, examiners only, that you do not write here. Always leave that column for them. Then draw a line. If this is that column, then that means you have to draw a line here and write your rough work. So since this is practice, we'll just have our rough work here. But always bear in mind that you need to have a place where you do your rough work, not within your work area. So here, we'll write the number 1a, then the equation 8 raised to power minus 1 over 3. Here, two things come to mind. Minus means that it is reciprocal. So in this case, what should come to mind is that this is the same as 1 over 8 raised to power 1 over 3. Then, solving further, this is equal to 1 over cube root of 8. And cube root of 8 is 2. Therefore, 2 is our answer. Okay. So, in solving mathematics, we said that you need to make sure that you are clear. So, in doing that, part of it is making sure that your sign of equality aligns. It helps your work to look neat, and it helps the examiner to follow your solution. Okay, the second one, 1b, and 27 raised to power 2 over 3. So this is the same as cube root of 27 all raised to power 2. And this gives us cube root of 27 is what? What multiplies itself 3 times to give us 27? Is it 2? 2 times 2 is 4. 2 times 2 times 2. Will it give us 27? No. Then, is it 3? 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. So, the cube root is what? 3. Then, remember that we just solved what is inside the bracket. So, that now leaves us with raised to power 2. Then this is equal to 3 raised to power 2 means what? 3 times 3, which is what? 9. Okay. Then we go to another example. Okay, example number 2. We have 2a. 1 over 2 is equal to 4 raised to power x. So here we now look at this. Most often when we have what we are looking for at the right hand side, some people find it difficult to handle. So the first thing I'll do here is to move what is on my right hand side. I'll move it to the left hand side. So I'll just swap them like this. Okay, so that is called transposition. So in this case, I'll say transposing four raised to power x is equal to 1 over 2. Good. This time I'm more comfortable with the equation. Then the next thing to look at is, can I make 4 and 2 to be on the same base? Yes. I can have something like 4 is 2 raised to power 2. Then the x is equal to 1 over 2 raised to power. This means 2 raised to power 1. So in this case, we have 2 raised to power 2x is equal to 2 raised to power then minus 1 when we take care of the reciprocal. Therefore, here we have 2x is equal to minus 1. Then if 2x is equal to minus 1, if we do the rough work here, 2x is minus 1. For us to make x to stand alone, we need to divide through by 2. So we have divided by 2, divided by 2. This will cancel this. X is equal to minus 1 over 2. Therefore, x is equal to minus 1 over 2. And that's our answer. Okay. Then we go to the next equation, which is 2b. Here we have 5 raised to power 2x plus 1 is equal to 1 over 25. So we look for how to make them to be on the same base. This will give us 5 raised to power 2x plus 1 is equal to 1 over 25 is 5 raised to power 2. Therefore, and this is the same thing as 5 raised to power minus 2. Therefore, here 5 raised to power 2x plus 1 is equal to 5 raised to power minus 2. This implies that the index plus 1 is equal to minus 2. Here we have 2x, subtracting 1 from both sides, minus 2, minus 1, then equal to what? Minus 2 minus 1 is what? Minus 3. Minus, you add, but you remember to put minus before your answer. So we now have x dividing through by 2x by 2. We have x is equal to what? Minus 3 over 2. Or minus 1 whole number 1 over 2. That's our answer. Okay, so with this, we have concluded our exercises on indices. So this time, let's discuss standard form. Standard form. Standard form usually goes with indices. It is used in sciences to compare very large and very small numbers. Example, large numbers like the distance between the sun and the earth and the mass of the earth. For instance, we have this number 149,597,871 kilometers. Okay, so if we change it to standard form, this number just becomes this. And the mass of the earth, which is this very huge number, will become this. So this makes it simple to work with. A standard form is expressed as a times 10 raised to power n. If you look at this, you will now see in that form, this stands for the a. Then this is the times. Then you have the base of 10. Then the index. Okay, but this time the a is a number greater or equal to 1. and less than 10. And n is an integer. It's either positive or negative. That is a positive number or a negative number. Okay, so standard form is better learned with examples. So we have, usually we start with our number 3a, then the question 7300. So standard form. So to make it to be in standard form, it has to be of the form a times 10 raised to power n. And a has to be a number between 1 and what? 1 and 10. So in this case, we have the number here between 1 and 10 is 7.3. Okay, so usually what this is that if we take 7.3, it will be multiplied by 1000 for us to be able to get this back. Okay, so in that case, 7.3 times 10 raised to power 1000 means 10 times 10 times 10, which is 1000. So 10 raised to power 3. Okay, so this is in standard form. Okay, so but there is another way that I'll teach you that is more straightforward and much faster. We have 7300. If we have it, the first thing we need to note is the position of the decimal point. That means it's here. So you can as well have other zeros here, it doesn't matter. Now the concern will be you get your a, which has to be between 1 and 10. So here the a will be 7.3. That means the decimal point now has to move to this place. Then times 10 raised to power, we now check the number of times this will move. 1, here, 2, 3. So it will move 3 times. Raised to power what? 3. So this gives us the same as this. Okay, so going forward we will use this approach because you'll see it's even more useful while doing the one with positive integer and doing the one with negative integer. Okay, then the next one is 3b. 892000. Here the position of the decimal point is here and it needs to be here for the a to be between 1 and 10, and this gives us 8.9 times 10 raised to power. How many moves will the decimal point make? It will make 1, 2, 3, 4, 5 to come to this place. So 10 raised to power 5. So let us take it to the next level, the one with negative integer. We have 4a and the equation is 0.0501. Here the same rule applies. We have to have a times 10 raised to power n, where a is a number between 1 and 10. So if we put it here, 0.05 is not between 1 and 10. If we move it here, 0.5 is not between 1 and 10. Then if it's only when we move it here that we have 5.0, which is a number between 1 and 10. So in that case, we have 5.01 times 10 raised to power. Then we check how many moves it will make to get to that 5 point. 1, 2. So in this case it will be 2. But this time will it be plus 2? No, it will be minus 2. Okay. So why minus 2? Because the transition now is to the right. For the positive integer, it was to the left. The move. Okay. So we take another example. 4b. We have 0.000763. Then the first thing is to get a, which is a number between 1 and 10. So you will ignore the whole of this 0 and get 7.63 times 10 raised to power. How will this move? It needs to be here. So how will it get there? 1, 2, 3, 4. So 4 to the right, which is what? Minus. So we have minus 4 in standard form. Okay. So with this, we've actually given the background of what you need to know. The test of the pudding is in the eating. Let us check how SSCE and UTME ask the questions. Now we have 5a. It says simplify 2 raised to power minus 3 times 16 raised to power 3 over 4 times 2 raised to power 0. Here we have 2 raised to power minus 3. We can now simplify this times 16. Can we make it to be on base 2? Yes. What is 16? 16 is here if we simplify, we have 4th roots of 16 all raised to power 3 times 2 raised to power 0 to complete. Okay, so this gives us 2 raised to power minus 3 times 4th root of 16 means what we multiply itself 4 times to give us 16. So, and 2 it is. 2 times 2 times 2 times 2. Here we have 2 times 2 is 4 times 2, 8 times 2, 16. So the answer here is 2, then raised to power what? 3 times 2 raised to power what? 0. Remember, we know that any number raised to power 0 is 1. Here, either we'd say 2 raised to power minus 3 because they have common base plus 3 plus 0. So in this case, minus 3 plus 3 is 0 plus 0. So everything is 0. So this gives us 2 raised to power 0, which is what? 1. Okay, so that is the answer. Then, here, there is some other thing I would like you to get to master here. Say 2 raised to power minus 3 times 16. If we raise it to power 2, to base 2, will be 2 raised to power 4. And it's already raised to power 3 over 4. Then times 2 raised to power 0. So, here, we'll get 2 raised to power minus 3 times 2 raised to power 4. We cancel 4. And we have 3 remaining times 2 raised to power 0. So at this point, you will now see that this and this are the same. So it's simply another way of manipulating this. Okay. 5b. 5 into 2 raised to power x minus 3 is 160. So now we can reduce further by dividing through by 5. Dividing both sides by 5. We have remember, whenever you have sign of equality, whatever you do on the left hand side, you do the same on the right hand side. So divided by 5, divided by 5. This we cancel this to give us 2 raised to power x minus 3 is the same as this into this to go 3 times into 10, 2. Okay, then the next thing we need to look at is, can we reduce 32 to a number in base 2? Yes. So it will be 2 times 2 times 2 times 2. That is 16 times 2, 32. So 1, 2, 3, 4, 5. So we have 2 raised to power x minus 3 is equal to 2 raised to power 5. Therefore, here we have x minus 3 is equal to 5 because of space. X is equal to 5. X is equal to 5 plus 3. Adding 3 to both sides is equal to 8. Okay. Then finally we have 5C, where we are asked to evaluate 0.0035 over 0.210, leaving our answer in standard form. Okay, so this time we might decide to change both of them to standard form. So it will be, the numerator will be 3.5 times 10 raised to power, to move 1, 2, 3 places to the right, that is minus 3, all over 2.1 times 10 raised to power. This will move only one place, minus 1, to get that. So this will give us 3.5 over 2.1 times 10 raised to power minus 3, then minus the denominator. The index of the denominator is minus 1. So you have to be careful to present it this way. The rule is that the index of the numerator will subtract that of the denominator, but that of the denominator is already minus. So that's why we say minus, then in brackets, minus 1. So this gives us, we pull our calculator here. Here we have 1.666. It continues, so we cut it here and say times 10 raised to power minus 3. Now, how do we resolve this? When we have minus times minus, becomes what? Plus 1. So remember, minus times minus is what? Plus. Minus times plus is minus. Plus times minus is minus. Plus times plus is what? Plus. So this is very important to note. Then this gives us 1.667 times 10 raised to power minus 3 plus 1. Then it means us minus what? 2. That's our answer. I hope this video has been informative to you. Thank you for watching. For more information on Ivory Gate, JAMB, SSCE, private home lessons, common entrance tutorials, and computer training, call our numbers today or visit our website at www.ivorygateonline.com. Learning to know it and to succeed in your exams. Thank you.